Okay, so we're on page 14, and I'm graphing the first one, so I got it to work. I don't know what I was putting in wrong there, but I did get it to work. Hopefully, I got it to work quite easily on my calculator. This is an app. I think I maybe had a weird space in there. Anyways, I have my x cubed minus 3x squared plus 2. That's our function, and we graph it. And then we can see from the graph what it looks like. So hopefully you got the same thing. So now you can do that, and you can do the other two. Remember, when you're in here, when you're doing functions that are greater than 2, you can use this little up arrow to do that. So I hit the X, then the up arrow, and then I put my 3 in. Okay. So that will give you that for your cubic function, okay? But I've got my function there, and I graph it, and that's what it looks like. Hopefully you have that, and you can do the other ones. And we're going to go back to the sheet now. So if you need to pause to fill out your sheet, do so. So let's take a look at what these look like. So we just saw our graph there. I'm going to freehand it. So it goes up, and then down and up, something like that. I'm going to sketch the other two now just because it's easier for me to do it at the same time. When I sketch the second function, it goes up, goes down, and then up. Okay, something like that, a little more beautiful. And when I sketch the last one, it goes like this and like this. So it doesn't quite have a turning point, but we do see a little hiccup, so to speak, in that graph. Hopefully that's what your 3 graphs kind of look like, except a lot more uniform and more, with the support of the technology better. So it is a sketch, and I always say sketch is an approximation, doesn't have to be a work of art. So let's answer our questions. So for the first one, the degree is 3. Second one, the degree is 3. Third one, degree is 3. First one, the lead coefficient is 1. There's a little invisible 1 there. Second one, the lead coefficient is 3. And the third one, the lead coefficient is -1. Remember, we do have an invisible 1 there. The constant for the first one is 2. Constant for the second one is 48. And the constant for the last one is 9. Okay. So actually, I got to resketch that one because it crosses a little bit differently, doesn't it? It crosses above the x-axis. So it's kind of like that. Sorry. Sketches do have issues, and that we should have certain things correct. Number of x-intercepts. Well, for this one, we have 1, 2, 3. So we have 3 of them. Sorry, I got a little off there. For the second one, we have 1, 2. And for our third one, we have just 1. Number of y-intercepts. I have 1, 1, and 1. Only one y-intercept. Value of the x-intercept. So I'm going to use my trace function on my calculator. And when I do that, I determine it's -0.7, 1, and 2.7. So that's where those 3 crossings are. For the second one, it's -4 and -2. So that's those 2 crossings. And for the final one, it's 1.3. Value of the y-intercept. Well, for our first one, it's 2. Our second one, it's 48. And our third one, it's 9, which is coincidentally the constant. That's what you probably notice with all of our functions. End behavior. So this one here is going from 3 to 1. As is this one, 3 to 1. This other one, the negative function, is going from 2 to 4. That might be why. Domain, X is in the set of real numbers. X is in the set of real numbers. And X is in the set of real numbers. And the range, Y is in the set of real numbers. Y is in the set of real numbers. And Y is in the set of real numbers. Number of turning points. Well, in this one I have 2, and in this one I have 2, but in this one, the third one, I don't really have a turning point. What I have though, so I have no turning points, but I do have is an inflection point. So I have this weird inflection point where it kind of wants to change direction, but it doesn't completely. So it's that hiccup I spoke of. Absolute value, max or min? No. No, no. Local max or min? Well, I have a local max between 0 and 2, and a local min between 2 and -2. So those are these points here, right up here and right down here. So I've got a local max and a local min between those two at those 2 points. Okay. For the second one, I have a local max here and here. So what are those points? Local max is at -3.3, 3.6, and you can use your calculator to find that using the trace function. And then I have a local min at -2, 0. I do not have a local max or min because I don't have turning points for that last one. So we may notice with cubic functions that we either get 2 turning points or an inflection. Our domain is X is in the set of real numbers, and our range is Y is in the set of real numbers. We may notice that the y-intercept is equal to the constant. That's for all of the functions though. There might be some other things that you notice when you see that one. Feel free to add any other comments of things that you might have noticed when you were looking at this. Sorry about that. Once again, I tapped the side and skidded off to another page. But I'm back. Doo-doo. So, now we are on page 15. Yes, this lesson is a longer lesson because we're looking at a lot of different things, right? So, summarizing and analyzing the characteristics of graphs and polynomial. How is the maximum number of x-intercepts related to the degree of any polynomial function? Well, the degree equals the maximum number of x-intercepts. Now you might say, well, what about that first one where it was right on the x-axis? That's kind of a unique case, and that's only because it is on that axis that you get that infinity happening, okay? So that's a special case. But a degree of 1 will have 1 x-intercept. Degree 2 could have up to 2 x-intercepts, and degree 3 could have up to, right? It's the maximum number. It's not the absolute number. Do all polynomials of degree 0, 1, 2, 3 have only one y-intercept? What is the y-intercept for any polynomial function? Yes, only one. And what is the y-intercept? Well, I talked about it on the last page. The y-intercept equals the constant term. And that's because the y-intercept happens when x equals 0. So if you put a 0 into all those variables, all you're left with is the constant term. What are the domain and range for all polynomial functions? Well, domain for all polynomial functions is x is in the set of real numbers. The range varies. For degree 1 and 3, y is in the set of real numbers. For degree 0, y is equal to the constant. For degree 2, y is either greater than the min, greater than or equal to the min, or greater than, less than the max. Okay? So it depends on the degree for your y, for your range, but for your domain, it's always x is in the set of real numbers. Explain why some cubic polynomial functions have turning points but not maximum or minimum values. Well, they can have inflection points. So those that have inflection points, they have no local maxes or mins. And that's because the formula has kind of smoothed the curve out a bit, just with the other parts of that area of that formula. So it's kind of made it less steep, so to speak, and less shallow. Like it's just kind of smoothed it out. How is the leading coefficient in any polynomial function related to the graph of the function? Well, the leading coefficient tells us about the end behavior. So, for degree 1 and 3, if it's positive, it goes 3 to 1. If it's negative, it goes 2 to 4. For degree 0 and 2, if it's positive, it goes from 2 to 1. If it's negative, it goes from 3 to 4. So this one is going to look like this, right? Or this one will look like this. And for 0, it's just a matter of whether or not it's above or below the x-axis, right? Okay? But that is the pattern. Okay. Example 4, using an equation to determine the characteristics of a graph. So, determine the following characteristics of each function using its equation without using technology. So we're just going to look at the equation. So our first one, well, it's a constant, right? So let's answer the question. Maximum number of x-intercepts. Well, it is not f of x equals 0. So that means it's just going to have that means it's going to have 0 for its x-intercepts. It's not going to ever cross it, because it's going to be a straight line at -3. Y-intercept, well, the y-intercept will be at -3. Maximum number of turning points, well, degree 0 has no turning points. End behavior, well, it's negative, so looking at our rules up there, it's negative, so it's going to go from 3 to 4. And domain, well, domain is always x is in the set of real numbers, unless it's f of x equals 0. All right, next one. Well, our next one is degree 1, right? Degree 1. So it's linear. Okay? So, maximum number of x-intercepts. Well, looking back, our degree equals the maximum number of x-intercepts. So the degree is 1, so the maximum number of x-intercepts is 1. The y-intercept is equal to the constant. Well, the constant is 1, so that's what the y-intercept is. Maximum number of turning points? Well, degree 1 doesn't have any turning points, so 0. It's a straight line. End behavior. Well, looking at our rules, the coefficient is negative, so it should go from 2 to 4. And then our domain, as always, x is in the set of real numbers. Okay, we can tell a lot. Now we're going to look at two others. So here we have, dun, 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 we have a quadratic, right? Okay, that's a Q, hard to believe. So let's think. It's got a -2, okay, but quadratic, maximum number of intercepts, that's equal to the degree, which is 2. Y-intercept, well, that's equal to the constant, so that's 8. Maximum number of turning points, 1. It's a parabola, so it only has one turning point. End behavior. Well, the coefficient is negative, so if we think about our rules for end behavior, when it's degree 2, if it's got a negative coefficient, it's going to go from 3 to 4. So that was on the other page. And our domain, as always, is x is in the set of real numbers. Okay, so there's a lot of things we can tell about this. Now here we have a cubic function. Maximum number of x-intercepts, it's cubic, it's equal to the degree, which is 3. Y-intercept equal to the constant, which is -10. Maximum number of turning points is 2, because it's a cubic. All right. And end behavior, we have a positive. So if we look back at our other page, it's going to go from 3 to 1. Okay, and our domain, x is in the set of real numbers. Alrighty. Okay, so let's take a look. So we're being like little Sherlock Holmes. We're using the information given to tell some other things. So this is matching the polynomial function to their graphs. So what I want you to do is I want you in a moment to pause your video, do your matching, and then we'll come back and we'll see if you got them right. Okay, so first one is I, and it is a cubic function. So it could be either G or P. So those are my two options. They both go through -2. Which one could it be? They're the same. They're identical, so it doesn't really matter, does it? Interesting. Oh, no. Well, one of these should have a negative sign. P should... I see nothing different between those two. So I think there's an error. Yeah. Well, we could match it up with P of x. And that would mean the other cubic one would be G of x. I think one of those two should have a negative sign. Just for correcting those. There's a little bit of a mistake there. I might see what I can do about that. 2 is a straight line, as is 6. So let's find the 2. So I've used this one and I've used this one. 2 could be, let's see, it could be H or it could be Q. Oh, I see. Depends on whether A is negative or positive. So if we have a negative value for A, it could be either one of those. So this could be PX or could be GX and vice versa. And then for these ones, depending on what, oh, it does have that. Ha ha ha. Rewind, Mrs. Finley. So this one has A is positive. So this does need to be P. And this has A is negative. Similarly here, A is negative. And here A is positive. So that tells me that if A is positive, then this needs to be Q of x. And if A is negative, then the slope is negative. So this needs to be H of x. Okay. Now we have our, sorry, I wasn't reading that part, and that's pretty important. So here A is positive, and the other one, similar function, A is negative. So if A is positive, then it's got to have a minimum, remembering back to our quadratic. So this is going to be f of x. And if A is negative, it's going to be a maximum. So this will be k of x. Okay. Hopefully you got them all right. Hopefully you saw the A greater than less than 0, unlike myself. All right. I'll know for when I teach the class live. Woohoo! I always do these before I do the live class, which is a good thing, right? Okay. Example 6. Reasoning about the characteristics of the graphs of polynomial functions. So for each set of characteristics, sketch the graph of possible polynomial functions. So we're looking at this one. We know that y has got to be greater than -2 for the range, and the y-intercept is 4. So we know that that means there's a point at 1, 2, 3, 4 right there. Now, y has to be greater than -2, so that means that if we sketch in a line at -2, y cannot go below that, right? The thing is, we only have the y-intercept and that restriction of where y can be and y can't be. So we could draw it like so. Okay. So as long as it touches on the -2, or it could go through this way as well. So either one of those would be acceptable. Okay. We know that it's got to be greater than -2, so it's got to be a minimum. So we know our quadratic would go up that way. And this would also tell us that it is a quadratic. So looking for the clues and then drawing your sketch. Next one. The range is y is in the set of all real numbers. So that tells us that it's got to be degree 1 or 3. Right? And then it says turning points. Well, can't be number 1. So this has to be degree 3. So it's got a turning point in quadrant 3 and a turning point in quadrant 1. So if we put a point for quadrant 1 and a point for quadrant 3, we're going to sketch in a cubic function that goes through both of them. And again, it's a sketch. Doesn't have to be perfect. And you could make those points anywhere in 1 or 3. Okay? So that's just taking some of the clues laid out and saying, okay, what could this look like? So there's a lot of information there. It's summarized on these last 2 pages. So read through these purple chunks. You can, it's in your note package, so I know you can read them. This kind of summarizes all of the stuff. This is a beautiful document here. It kind of outlines all of the qualities of constant, linear, quadratic, and cubic functions. So this is a good cheat sheet or just a guidance sheet for studying. Tells you all of these, the rules for the various things, and those assumptions we make based on what kind of function it is. Okay, so this has been part 2 of the first lesson, lesson 1A in polynomial.